Hello students, this is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad. In this video, I will take you through the solutions of the mathematics part of NTA test paper number 6. Parth Tank Institute is also presenting to you the solutions of all the NTA test papers, so please do follow them. The first question. Sin of AX plus cos AX and mod of sin x plus mod cos x are periodic with the same fundamental period if A equals to. First of all, sin AX plus cos AX. Now we know that both sin nx or cos nx are periodic with a period 2 pi upon n, right? Sin x is periodic with 2 pi, sin 2x will be periodic with pi, so on. Therefore, both these functions are periodic with 2 pi by a. Okay, so summation of both these functions is also periodic with 2 pi by a. What about mod sin x plus mod cos x? Now we know that the graphs of sin x and cos x are like this, right? This is sin x and cos x starts from here, and at 0 it becomes, at 90 it becomes 0, right? So for cos x, there is a bit of a change at 90 pi by 2. So here, what would become is mod of cos x, right? So its negative would come. Let us see that technically here. What I am trying to say is, let us keep this as f of x. Okay. Now, in 0 to pi by 2, this is going to be equal to sin x plus cos x because both are positive. Now let us take an angle pi by 2 plus x, okay, that is something in the second quadrant. Now that would give me mod of sine of pi by sine of pi by 2 plus x plus mod of cos of pi by 2 plus x. What is this? Sine of pi by 2 plus x is cos x and it is positive. And this would be cos of pi by 2 plus x will become minus sin x because second quadrant is negative. And this, when you take the mod, is going to become plus, which is equal to f of x. So you see, f of x plus 2 is equal to f of x. Sorry, x plus pi by 2 is equal to f of x. Therefore, if I write it down, f of x plus pi by 2 is equal to f of x. This means that this function is periodic with pi by 2. Therefore, the first function was periodic with 2 pi by a and this is periodic with pi by 2. So to find the value of a, we equate these two and we get a is equal to 4. So the answer is 4, option B. Very simple. Sin x, cos x are all periodic with 2 pi by a. Mod sin x, mod cos x, you evaluate in 0 to pi by 2 both are positive. In pi by 2 to pi you get the same answer. Okay, moving on to question number 2. The differential coefficient of log x base 10 with respect to log 10 base x. That is, if you take u is log x base 10 and v is log 10 base x, what they are asking us to do is du by dv, the differential coefficient of u with respect to v. So du by dv is nothing but, du by dx upon dv by dx. Yes. So du by dx is straightforward, but be careful, you differentiate after you change the base to base e, that is log of x base e by log of 10 base e, because differentiation works only for natural logarithms. Therefore, this becomes, when you differentiate du by dx, this is a constant and log of x base e is the usual 1 by x. Alright. The same way here also, remember this is our target. Alright. V is nothing but log 10 base e by log x base e. Now this of course is a constant and it is like 1 by log x. So when you differentiate this, 1 by x, when you differentiate it becomes, okay, log 10 base e is constant, and this becomes minus 1 by log x base e the whole square, and 1 by x for the log, or dv by dx can be written as log 10 base e by x into log x base e the whole square with a minus here. Now if you need du by dv, divide this by this. So du by dv, which is nothing but du by dx upon dv by dx is, let us see, the first one was 1 by x log 10 base e, and the second one is minus log 10 base e by x log of x base e the whole squared. Now this x is going to vanish, and after a bit of a simplification I get log x base e the whole squared by log 10 base e the whole squared with a minus, or this can be written as log x base e by log 10 base e the whole squared. And this again, change of base rule, you can combine it to make it log x base 10 the whole squared. So the answer is minus log x base 10 the whole squared, option B. Moving on to question number 3. ABC are the angles of a triangle, and 1, 1, 1, determinant 1, 1, 1, 1 plus sin A, 1 plus sin B, 1 plus sin C, sin A plus sin squared A, sin etc. is 0. Then the triangle ABC is what? Okay, very simple sum actually. Let us just simplify this determinant a little bit. We can write it as, quickly, it would be 1 by, if I subtract R2 minus R1, okay, so it will become sin A here, sin B here, and sin C here. And after you do the subtraction, subtract R3 and R2. I'm just saving some space here, not writing the whole determinant again. I can get sin squared A, sin squared B, sin squared C. Is all right? Yeah? Okay. Now, from here there are two ways to proceed. The easiest is, they have given that this determinant is equal to 0. Now if you evaluate this determinant, basically the easiest way to do is to make these two zeros and then evaluate this determinant. So to do that, you do column 2 minus column 1 and column 3 minus column 1. Remember, this determinant is going to be, is 0 is given. 1, 0, 0 sin A, and here I have sin B minus sin A, and here I have sin C minus sin A. And then the same way, this is sin squared A. Here again I have sin square B minus sin squared A, and then sin square C minus sin square A. Okay. Now, of course, you can simplify this term if you see that sin B minus sin A is common and can be taken out, and here sin C minus sin A is common and can be taken out in this column. So from the second column, if I take sin B minus sin A, and from the third column, here sin B minus sin A, and from the third column I take sin C minus sin A, I would get 1, 0, 0 sin A sin squared A. This is 1. Here I get sin B plus sin A, because it's A squared minus B squared, right? A minus B, A plus B. So here it is sin C minus sin A, and this becomes 1, excuse me. I have taken this common, so this becomes 1, and I get sin C plus sin A. Now if you evaluate that determinant carefully, you will get sin B minus sin A into sin C minus sin A into sin B minus sin C is 0. Now this implies either of these two angles A, and either A should be equal to B, or B should be equal to C, or C should be equal to A. So if two angles are equal, then we know that the triangle is isosceles. Alright. So the answer to this problem is isosceles. Whether it is right angled isosceles or equilateral. Equilateral also it can be that all three are equal, but that needs some more specification. Alright. Another way is also to look at this, and you know the sides are proportional to the sine of the angle, right? So I can say A is equal to some constant into sine A, B is some constant into sine B, and C is some constant into sine C. So you can convert that whole matrix into A, B, C also, A squared, B squared, C squared, in terms of sides, and this also is nothing but A minus B, B minus C, C minus A, which implies that any two sides are equal and isosceles. This is another way. Alright, question number 4. The contrapositive of the statement, if two triangles are identical then they are similar, is. Okay. Remember, contrapositive of if P then Q, the contrapositive is if not Q then not P. For us, P is two triangles are identical, okay, and Q is they are similar. Now the answer is if P is then Q, then the contrapositive is, as I told you, if Q, not Q then not P. So if it is not Q, then the statement becomes if triangles are not similar, then not P will be, or not identical, then triangles are not identical. Okay. So this is if triangles are not similar, they are not identical, is option A. So the answer to this is option A. Simple. If P then Q, the contrapositive is if not Q then not P. Question number 5. F of x is equal to a minus x minus 3 the whole raised to 8 by 9. The maximum value of f of x is how much? Now see, the obvious way of doing the maximum minima here is to differentiate this, but when you differentiate this, what do you get? F dash of x will be 1 minus of x minus 3 power minus 1 by 9 by minus 1 by 9, or this becomes minus, or let's say plus 9 by x minus 3 power 1 by 9. Now this is a singular function. At x is equal to 3, this is not defined. Therefore, this it's not differential and it is not 0 at any particular value of x except at infinity. So we won't use this approach, rather just analyze this function a little bit. This x minus 3 to the power 8 by 9 is of course x minus 3 to the power 1 by 9 the whole power 8, let us say. Now this you can say has 9 different roots, right? Because anything power 1 by 9 has 9 roots. And of those 9 values, only one will be real, all the other will be complex conjugates. So let us consider that one real value. Now that one real value can be either positive or negative based on whether x minus 3 is positive or negative. If x is less than 3, this is negative, so x minus 3 raised to 1 by 9 will be negative. If x is greater than 3, this will be positive and this term will be positive. However, whether this term is negative or positive, x minus 3 power 1 by 9, the whole power 8 is going to be always positive. Right? So f of x is a minus something positive always here. So f of x is always going to be less than or equal to a. Correct? So the maximum value is f of x is equal to a. Maximum is a. And that will occur when x is equal to 3. You put x is 3 here, this becomes 0. So f of x is equal to 3. F of x is equal to a is the maximum. So the answer is a. No calculation needed at all. And no worry about x power 9. Only to realize that this whole thing is a positive number. Okay. Let's move to question number 6. The value of sine of cot inverse of x is how much? Right? Now, if cot inverse of x is theta, that is x is cot theta, then we can complete the triangle, you know the usual procedure, theta. Cot theta is adjacent by opposite, right? So the hypotenuse is x squared plus 1. So sine theta would be opposite by hypotenuse, which is 1 by root of x squared plus 1. So substitute that here. So this is sine of theta is nothing but sine inverse of 1 by square root of x squared plus 1, and therefore this is 1 by square root of x squared plus 1 plus x squared, which is option C. Right? Moving on to question number 7. The area bounded by the curves y is equal to x squared and y is equal to 2 by 1 plus x squared is what? Okay. Now of course we know that the curve y is equal to x squared is a parabola open up vertex 0. It's a bit difficult to draw on this tab here and then to get proper curves. Anyways, and how is this curve 2 by 1 plus x squared going to look like? At x is equal to 0, it will have a value 2. X is equal to 0, y is 2. So this is 0, comma 2. And then at x is equal to 1 or minus 1, it is going to be 1. So those points actually lie here, 1 comma 1 and minus 1 comma 1 are both on the parabola and the curve. And it is always positive and it will go to 0 as it goes to infinity. So the curve is going to be like this. Now we need this area. Now see, already we have managed to figure out the points of intersection, so the limits are known. However, the proper way of finding the points of intersection, just for the sake of completeness, is equate the two curves. Y is x squared and y is 2 by 1 plus x squared. Equate them both. X squared is 2 by 1 plus x squared, or x power 4 plus x squared minus 2 is 0, or x plus 2 in x squared plus 2 into x squared minus 1 is 0. You get x square is minus 2 or 1. Now this is not allowed, so x will be plus or minus 1. Those are these two values, minus 1 and plus 1, and y would be 1 there. So the answer is y of this function minus y of this function integrated from these two limits. That is integral of 2 by 1 plus x squared minus x squared dx from minus 1 to 1. This is the area. Now you see that both these functions are even functions. So from minus 1 to 1 can be written as 2 times 0 to 1, 2 by 1 plus x squared minus x squared dx. So this becomes 2 times tan inverse of x, right? Integral of 1 by 1 plus x squared is tan inverse of x minus x cube upon 3 from 0 to 1. Now I substitute 1 here, I get 2 times 2 into pi by 4 minus 1 by 3, and then if I substitute 0 here, it becomes 2 times 0 minus 0. Therefore the answer is 2 into pi by 2 minus 1 by 3, or pi minus 2 by 3 square units. So the integral, the area is pi minus 2 by 3 square units, option B. Very simple problem. Find the points of intersection and then integrate between the two limits. Question number 8. Now this is an interesting problem. And the value of limit x tends to 0, x to the power 6000 minus sin x to the power 6000 by x squared sin x to the power 6000. Now there is a way of doing this using L'Hospital's rule also. However, I will show you one technique using the series expansion and how the whole thing can be conveniently solved using series. Now remember, the series expansion of sin x is x minus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. I am going to approximate it using two terms alone because we need sin x to the power 6000. Now this can be written as x minus x cubed by 3 factorial is 6 plus higher powers the whole power 6000. Now we will write the lowest two terms, the powers of the lowest two terms, which will be based on the first two terms alone, right? If you consider this as a binomial series, the first term is going to be 6000 C1, the first term power 6000, second term power 0, right? And then plus 6000 C0, excuse me, Then 6000 C1, x raised to 6000 minus 1 is 5999, and x cube by 6 power 1. And then the next one would be 5998 and this whole squared and so on. Let us just consider the first two terms. This is nothing but 6000 x to the power 6000 minus, what do I have here? I get, 6000 C0 is just x to the power 6000 minus 6000 by 6 x to the power 6002. This is going to give you the clue because the denominator is like 6000 power 2, right? I mean, more or less. So let's see here. So this becomes plus and so on to infinity. So if I use only these three terms, and if this is nothing but 1000, the numerator x raised to 6000 minus sin x raised to 6000 is x power 6000 minus this whole expression, that is x power 6000 minus x power 6000 minus 1000 x to the power 6002 and higher powers. So I get just 1000 x raised to 6002 and higher powers. Alright. So ignore the higher powers. Look at this limit now. This becomes limit x tends to 0. X, this numerator is 1000 x to the power 6002, and the denominator, the numerator of course if you say has higher powers of x, the denominator is also x squared into sin x power 6000. Now we already have sin x power 6000 here. So this multiplied by x squared. Now that would give me again x to the power 6002 plus I'll have 1000 x to the power 6004 and so on. So you see higher powers of x. Here also we have higher powers of x, higher powers of x. So this, if I take x to the power 6002 outside and cancel, here I'll get 1 plus powers of x. Okay. The same way in the denominator I'll get 1 minus powers of x. Apply the limit now. I have 1 by 1 and only 1000. Right? Quite simple if you use the series expansion. Of course, L'Hospital's rule, you can do some manipulations, but things are going to be a little bit tricky. I prefer using series whenever it is possible. So the answer is 1000, option A. All that I am doing is write the first two terms alone and get the first two terms of the binomial series, and then get the numerator, which is this, and the denominator, and then do the final simplifications. Question number 9. The value of the integral 4 to 10 box x squared by x squared minus 28x plus 196 plus x squared box dx is how much? Now this is simple if you identify quickly that this term in the bracket is 14 minus x the whole squared boxed plus x squared, right? And now of course you know integral a to b f of x dx is the same as integral, let's call this I, integral a to b f of a plus b minus x dx. So using this, you know this is a, let us say, for us, and this is b. The whole integral can be written again as a plus b, so that is 14 minus x the whole square. In the place of x you put 14 minus x. So here again it becomes 14 minus x the whole square plus 14 minus x the whole square dx. Now this is nothing but 4 to 10, 14 minus x squared box by x squared under box plus 14 minus x squared within box dx. Now this is also I. Add 1 and 2, the numerator and the denominator become the same. That is, if you add both left hand sides, this one and this one. The numerator also is going to be like box of x squared plus box of 14 minus x squared, and the denominator is also going to be box of x squared plus box of 14 minus x the whole square from 4 to 10. Now this is nothing but integral 4 to 10 1 dx, which is x from 4 to 10. This is 10 minus 4, or I rather is 6 by 2 3. So the answer is 3, option D. So remember, whenever the integral can be simplified like this using this rule, and then the numerator and the denominator becomes equal to 1, then you see that the integral is just 1 from the lower limit to the upper limit. So the answer is upper limit minus lower limit by 2. Okay, this is a very important JEE mains type question. Many problems like this are being asked in the exams these years, so keep sure of this identity. Question number 10. The shaded region in the figure represents. Now, this shape, this area here is A minus something, right? Now, is it A intersection B union C? Because B union C would be this full 2 circles. A intersection B union C would be this area alone. A union B intersection C. A would be the whole thing. B intersection C would be this part, right? What I mean is, let us say A intersection B union C would be this red area, not that gray area. A union B intersection C would be, A is the whole thing, B intersection C is this part. So all this area. So not the area that we know. Excuse me. Then we have A intersection B minus C. Now B minus C is this part. A intersection B minus C is only this part. So not that area. What about the last one? A minus B union C. A is the whole thing. B union C is this whole thing. When you subtract, you only get this part. So option D, A minus B union C is correct. Okay. Moving on to question number 11. If A sin squared x plus B cos squared x is C, B sin squared y plus A cos squared y is D, and A tan x is equal to B tan y, then A squared by B squared is equal to. Here A, B, C, D are distinct. They are not equal to each other. Okay. So we'll have to get something in terms of tan in these equations. So let us divide. Take the first equation, A sin squared x plus B cos squared x is C. Divide the whole thing by cos squared x. So this become A tan squared x plus B is C secant squared x. I am dividing the whole thing by cos squared x. Now secant squared x can be written as C into 1 plus tan squared x, right? This is nothing but 1 plus tan squared x. So this becomes C plus C tan squared x, or B minus C is equal to C minus A tan squared x, or tan squared x is nothing but B minus C by C minus A. Okay, let us do the second one. From this, B sin squared y plus A cos squared y is equal to D. So B sin squared y plus A cos squared y is D. Divide by cos squared y, and I get B tan squared y plus A is D plus D tan squared y. This is secant squared y. Secant squared y becomes 1 plus tan squared y. Therefore, A minus D is D minus B tan squared y, or tan squared y is nothing but A minus D. A minus D by D minus B. Now I have tan square x and tan square y, and they have given us one more condition, A tan x is equal to B tan y. B tan y is given. So A by B is going to be tan y by tan x, or A squared by B squared is going to be tan squared y by tan squared x. Now we have expressions for tan squared y and tan squared x. Tan squared y is a minus d by d minus b. By tan squared x is b minus c by c minus a. So when you divide, b minus c goes here, c minus a goes here. So this is a squared by b squared. The answer we need. A minus d, c minus a, b minus c and d minus b is option B. See, all the options are very close to each other. Make sure you choose the correct answer. There is one difference here, etc. etc. Very simple problem. Just find tan square x and tan square y. Number 12. The number of points from where perpendicular tangents to the curve x squared by 16 minus y squared by 25 is equal to 1 can be drawn is are how much? How many tangents? Perpendicular tangents. That is, see, we know that for both ellipses and hyperbolas, when there is an ellipse, x squared by a square plus y square by b square is equal to 1. There is a circle called director circle. If this is x squared by a squared plus y squared by b squared equal to 1, then this director circle has formed x squared by a square is equal to y square plus b square, and from any point on this circle you draw a tangent, you can show that they are perpendicular. Two tangents to the ellipse are perpendicular. Same way, and this circle is called the director circle, right? Director circle. Same way for a hyperbola also. If you have a hyperbola of this form, x squared minus a squared, x squared by a squared minus y squared by b squared is 1, then there will be a circle, a smaller circle, which is of the form x square plus y square is a squared minus b squared. Okay, now from any point on this circle you will get perpendicular tangents on the hyperbola. So the director circle for an ellipse is x squared by y squared plus is equal to a squared plus b squared, and it exists always because it is a positive term. Whereas here you have to be careful whether this exists at all. Take our hyperbola. In our hyperbola, a squared is 16 and b squared is 25. Therefore the circle is x squared plus y squared is 16 minus 25, which is minus 9. This is impossible. Sum of two squares cannot be a negative. So such a circle cannot exist at all. Which means that for this particular hyperbola there is no director circle. And therefore there cannot be any perpendicular tangents from an external point. You cannot find points which will give perpendicular tangents to the hyperbola. So the answer is actually C, 0. There are no such tangents, perpendicular tangents from any external point here. If you find, however, that this is a positive number, okay, if you find there is a positive number, then this circle exists, and therefore there are infinite points from which you can have perpendicular tangents on the hyperbola. Okay, let's move. Question number 13. The sum of the first 20 terms common between the series this and this is, okay. Now the first series is has common difference, is an arithmetic progression with common difference 4. First series, let us say D1. Now the second series has common difference 5, right? So we see already there is one term common, 11 and 11, okay? Now 11 after 5 terms in this series will become 5 times D, which is 31, and here 4 times D, D2 will give 31, right? That is the common term. The next common term would be, 11 is already a common term. The next common term would be 31, which will be plus 5 times D1. The next one would be 51, 71 and so on. The same way here, after 4 times D2 you would get 31. After 4 terms you will get 31, then 51, 71 and so on. So this is the AP that we have to, that is the AP that we need. The common terms are these. The common terms are an AP with A11 and D20. So sum of the first 20 terms, n is also 20. Therefore the sum of the first 20 terms is, you know the expression, right? N by 2, 2n plus A minus 1 times D. So it becomes 20 by 2, 40, sorry, excuse me, it is 2 into 11, 22 plus A minus, plus, my god, my mistake, 2A plus n minus 1D. 2A plus n minus 1D. So it is 22 plus n minus 1 is 19, D is 20. So this becomes 10 into 22 plus 380, 402, 402 into 10 is 4020, option D. Let's go to question number 14. Let 10 vertical poles standing at equal distances on a straight line, there are 10 poles standing on a straight line, all 10 subtend the same angle of elevation alpha at a point O on this line, and all the poles are on the same side of O. Basically they are saying that there are 10 poles, let's say this is O, all on the same side of O. Now the second pole, let's say equal distances, they are separated by equal distances. Let us say each distance is x. So the 10th pole, let us say somewhere here, this is the 10th pole, first pole, all subtend the same angle here. This is alpha, the angle alpha is the angle. If the height of the longest pole is h, that is the 10th pole is h, and the distance of the foot of the smallest pole from O, this is the smallest pole here, the distance of the foot from O is A, then the distance between two consecutive poles, this x is how much? This is very simple. If you notice that this whole length is 9x, right? There is going to be 9 intervals between the 10 poles, each of say distance x. So 9x is the total length. So total length here is 9x plus A. So tan alpha is nothing but h upon 9x plus A. Now since you see the answer is in terms of sine and cos, rewrite tan alpha in terms of sine alpha by cos alpha is h by 9x plus A. A bit of simplification now. 9x sine alpha plus A sine alpha is h cos alpha. Therefore, x will be, take A sine alpha that side and take the 9 sine alpha to the denominator. So it becomes h cos alpha minus A sine alpha by 9 sine alpha. H cos alpha minus A sine alpha by 9 sine alpha, which is 9 sine alpha in the denominator, these two, and with a minus in between, so option B. Okay, very simple heights and distances problem. Just mark the given parameters properly. 10 poles, same angle, so they are all of decreasing height and equal distances from each other. So this is 9x plus A, h by 9x plus A is tan alpha. Question number 15. Let u v w be vectors such that u vector plus v vector plus w vector is 0 if mod u is 3, mod v is etc. etc. The value of u dot v plus v dot u plus w dot u. Take the square of this vector, excuse me, u plus v plus w dot u plus v plus w. This is also equal to 0 because it is 0 dot 0. 0 dot 0 is 0. Now this we know is u dot u is mod u squared, v dot v is mod v squared, that is the magnitude, w dot w is mod w squared, and then I'll have u dot v and v dot u, both are the same. So the usual formula, 2 times u dot v plus 2 times v dot w plus 2 times u dot w is 0. Alright. Therefore, u dot v plus v dot w plus u dot w into 2, if I take 2, is nothing but minus mod u square minus mod v square minus mod w square. Now all this, the right hand side is known, and take this 2 to that side to get u dot v plus v dot u, v dot w plus u dot w is equal to u squared is minus 9 minus 16 minus 25 upon 2, or minus 50 upon 2, which is minus 25. So the answer is minus 25. Very simple problem. Just square it and then you get the answer. Question number 16, a permutations and combinations problem. The total number of ways in which 5 balls of different colors can be distributed among 3 persons such that each person gets at least 1 ball is. Okay, there are 3 persons. Let us say these are the 3 persons, P1, P2 and P3. Now each should get at least 1 ball. Okay, see there are 5 balls, each of different colors, and that colors part is not actually necessary, it's just to distract us. So each of these 5 balls can go to person 1, person 2 or person 3. So ball 1 can go to person 1, person 2 or person 3. Ball 2 can go to person 1, person 2 or person 3, so on. So each ball has 3 ways of being arranged. So 5 balls can be arranged in 3 raised to 5 ways, or 243 ways. Now there is an answer 243, but that be careful, because in this arrangement all 5 balls can be given in this 243. There are also ways in which all 5 are given to P1, or all 5 are given to P2, or all 5 are given to P3. So that has to be removed. That is, all 5 given to one person is 3 ways. Either all to P1, all to P2 or all to P3. This has to be removed, because that would leave 2 others without any balls, and the condition is each person gets at least 1 ball. So the balls cannot be among 1 person or cannot be among 2 persons also. Now 5 balls given to 2 persons. How many ways are there for this? Imagine there are only 2 persons, P1 and P2. Now the 5 balls are to be given here. There are 2 power 5 ways to do that. And in these 2 power 5 ways, 2 ways are going to be either all 5 balls to P1 or all 5 balls to P2. So 5 balls given to 2 persons will be 2 power 5 ways minus 2. That is 30 ways. So in 30 ways you can give 5 balls to 2 people alone. But these 2 people can be chosen in 3 different ways, right? Because there are 3 people, P1, P2 and P3, and you can choose P1, P2 or P2, P3 or P3, P1, and you can give the 5 balls to them alone, or 5 balls to them alone, or 5 balls to them alone. That is 30, 30, 30 ways here. So totally there are 90 ways. Therefore, of those 243, 90 ways have to be removed for the situations in which only 2 people have the balls, and 3 has to be removed for the situations in which only 1 person will have the ball, and this would give 150. Okay, so the answer is 150, option B. Don't rush to 243. This is only the total number of ways possible, but among that you remove the number of ways in which it can be given to only 1 person. All balls given to person 1, or all balls given to person 2, or all balls given to person 3. And then how many ways can these be given to 2 people? Right? 2 people means P1 and P2 takes all the 5 balls like this. So that is 2 power 5 ways. But in that 2 power 5 ways, 32 ways, 2 ways mean all 5 balls will go to these 2 persons alone. So to find out only the ways in which 2 people have the balls, you have to remove this 1 person having the ball in this situation. That is minus 2. Okay. So the answer, and then remember, you can choose those 2 people in 3 different ways. If you choose P1 and P2, and then they can have 30 ways in which they do, etc. And so 150 ways, everyone has at least 1 ball. Let us move to question number 17. The order of the differential equation whose general solution is given by y is c1 plus c2 cos x plus c3 minus C4 e to the power x plus 5, where C1, C2, C3 are arbitrary constants. Now the first thing that comes to your mind is the order of the differential equation is equal to the number of arbitrary constants. 5 constants, so answer 5, but no, because some of these arbitrary constants are not arbitrary at all. See here, take the second term, C4 e to the power x plus C5 can be written as C4 e to the power x into e to the power C5. Now e to the power C5 is a constant, and this whole thing, arbitrary constant into another arbitrary constant, is some other arbitrary constant. We can call it one particular constant k1, let us say k1 e power x. Same way, if you see the first two also, there is C1 plus C2 cos of x plus C3, right? This can be written as C1 plus C2 cos x cos C3 minus sin x sin C3. So this becomes cos x into C1 plus C2 cos C3 minus sin x into C1 plus C2 sin C3. Now these are just two arbitrary constants more, right? The whole term is one arbitrary constant. This whole term is another arbitrary constant. So this can be written as k2 cos x minus k3 sin x. So the actual solution is like k2 cos x minus k3 sin x plus k1 e raised to x. So there are only 3 arbitrary constants in this problem. So the correct answer is option C3, not 5. See how you can combine the arbitrary constants and make them 1. Any product of arbitrary constants, or a division of arbitrary constants by another arbitrary constant, or log of an arbitrary constant, or e raised to an arbitrary constant, they are all arbitrary constants. So combine them all together and then you guess that it is 3. Question number 18. In a test, an examinee either guesses or copies or knows the answer to a multiple choice question with 4 choices. The probability that he makes a guess, I am going to call it P of G, is 1 by 3. The probability that he copies the answer is 1 by 6. Probability that he copies the answer, let's say P of C is 1 by 6. Now they said that he either guesses or copies or knows, right? So the third option is probability that he knows the answer, which must be 1 minus these 2. When he doesn't guess or doesn't copy, that means he knows. So 1 minus 1 by 3 minus 1 by 6 is 1 by 2. So the probability that he knows is 1 by 2. Okay. The probability that his answer is correct, given that he copies it, is 1 by 8. Let us call P of y to be a correct answer. Y for yes, let us say. This is correct answer. They have given us probability that it is correct given that he copies, right? So he is correct given that he copies. Y given C is 1 by 8. And the probability that his answer is correct given that he guesses. Correct given that he guesses. This is correct given that he copies. Correct, Y is correct. Copies C. Y is correct, G. This is 1 by 4. Now what will be the probability of correct answer given that he knows it? 1. Because if he knows the correct answer, he will put that correct answer, right? Okay. So these are given. What is the question? The probability that he knew the answer to the question given that he answered correctly is, that is, probability of K given he answered correctly, Y, is how much? And this is a classic application of the Bayes theorem, right? We know that probability of K given Y is nothing but probability of Y given K into probability of K, the whole thing divided by probability of Y actually, right? It will be like this. Now this probability of Y alone can be written in terms of all the other probabilities. Probability of Y given C y given c into probability of c plus probability of y given g into probability of g, and the third term can be probability of y given k into probability of k. So you see, probability of y is from all three contributions. Correct answer, he knows the answer. Correct answer, copied. Correct answer, guessed. All this is the total probability that the answer is correct. And the numerator is only this contribution. That is the correct, he knows the answer, contribution is that. Okay. So let us substitute the values. Y given k is 1, k is 1 by 2. So the numerator is 1 into 1 by 2. And the denominator also becomes 1 into 1 by 2 plus P of y given c is 1 by 8 and 1 by c. Now c is 1 by 6. So 1 by 8 into 1 by 6. And P of y given g is 1 by 4 and g is 1 by 3. So 1 by 4 into 1 by 3. Now what does this become? 1 by 2, the whole thing divided by 1 by 2 plus 1 by 48 plus 1 by 12. Taking the LCM, 1 by 2 upon 48 is the LCM of course. So 24 plus 1 plus 4. Now this becomes 1 by 2 by 29 by 48, or you do the reciprocal, 48 by 29 into 1 by 2, which is 24 by 29. So the answer is 24 upon 29. 24 upon 29, option C. Question number 18, option C. Moving on to question number 19. The number of values of theta given, theta belonging to minus 3 pi by 2 to 4 pi by 3, which satisfies the system of equations 2 sine square theta plus sine square 2 theta is 2. And they have given another equation is, that is 2 sine square theta. Let us start with the first equation and simplify that. Sine 2 theta we know is nothing but 2 sine theta cos theta. Take this 2 sine square theta to the other side. I get 2 into 1 minus sine square theta. This becomes 4 sine square theta cos square theta is 2 cos square theta. Or to this side and take the 2 cos square theta common, I get 2 sine square theta minus 1 is 0. This means that cos theta is 0, which can happen if theta is an odd multiple of pi by 2, right? N is 0, 1, 2, etc. Or sine square theta can be 1 by 2, or sine theta is plus or minus 1 by 2, 1 by root 2. So theta can be all these 45, 135, 225, what do we have on the other side, 315, all these angles, multiples of pi by 4. Now we have to see how many such we have from minus 3 pi by 2 to 4 pi by 3. Sin theta can be both 1 by 2, 1 by root 2 or minus 1 by root 2. So let us just think about these values. That is from minus 270 to 240. In this range, how many angles satisfy this? That is sin theta is equal to 1 by root 2 or minus 1 by root 2. Now sin theta is 1 by root 2. We know in the positive range at least, theta can be 45, that is pi by 4, can be 135, 3 pi by 4, only these two values. Now in the negative range, sin theta is minus 1 by 2, can be theta is, minus 1 by root 2, theta can be 5 pi by 4 and 7 pi by 4. Now 7 pi by 4 is 315 degrees, which is beyond this side, right? So only these three values. There is nothing but 45, this is 135 and 225. So same way in the negative side also all these three values can be there, because on the negative side minus 45 and minus 135 will be for sin theta is minus 1 by root 2, and on the minus 225 will be sin theta is equal to 1 by root 2. Therefore the actual solutions are minus 5 pi by 4, minus 3 pi by 4, pi by 4, minus pi by 4, then pi by 4, 3 pi by 4 and 5 pi by 4 in this range. Okay, and of course we have cos theta equal to 0. Also within this range it can be pi by 2, 2 pi by 2, that is pi, in this range basically. I mean it can be pi by 2, 3 pi by 2 still possible. Is 200, no, 3 pi by 2 is not possible because it is only 240 degrees, but minus 3 pi by 2 is possible. So these are the two for this in this range. Only these two values are satisfied. Satisfy the this and minus pi by 2 also. Excuse me. So I can have, let me write it properly. For cos theta 0, this can be minus pi by 2 or pi by 2 or minus 3 pi by 2. Now there are 3 values here and 6 values here, and we have to see about the second equation. Second equation says sin 2 theta plus cos 2 theta is tan theta. Okay, I'm telling you that theta has another 3 values, minus pi by 2, minus 3 pi by 2 and pi by 2. 9 possible solutions of equation 1 are there. Now of these, second equation cannot take any of these because tan would become undefined at all these 3, and sin, this can be only maximum of plus or minus 1. So this 3 we can eliminate them. How about these values? Would they satisfy this? Let us check. Now sin 2 theta, see cos of 2 theta for all these numbers, okay, all these numbers, cos of 2 theta is going to become negative, right? I'm sorry, 0, because it will be cos 5 pi by 2, cos 3 pi by 2, cos pi by 2, cos minus pi by 2 and all that. So only this term, that is sin of minus 5 pi by 2, sin of that is this equation, for all these values cos 2 theta will be 0. So I should check for sin 2 theta is equal to tan 2 theta, tan theta. Take any one value, let us say sin of minus 5 pi by 4. This would give sin of minus 5 pi by 2 should be equal to tan of minus 5 pi by 4. Now minus 5 pi by 4, tan minus, this can be written as minus, drop minus on both sides, sin 5 pi by 2 is tan 5 pi by 4. Now this is 1 and this is also 1. Third quadrant tan is positive. Sin 5 pi by 2 is nothing but 90 degrees, which is 1. Likewise, you can check that all these satisfy this equation. Let's say 3 pi by 4 or plus 5 pi by 4. For plus 5 pi by 4, this would become 5 pi by 2 and this would become 5 pi by 4, right? So minus or plus doesn't matter. So same way, 3 pi by 4, you put 3 pi by 4, 3 pi by 2 is minus 1, 3 pi by 4, 135 is minus 1, matches pi by 2. So this, all 6 values here will satisfy the second equation also. Therefore the solution, number of solutions are only 6 values in that region. So answer is option C, 6. Very simple, only solve the first equation and find the 9 values and then show that these 3 are not allowed, whereas these 3 are valid solutions, or all 6 are valid solutions, and show, therefore the answer is 6. Question number 20. If the 3 distinct lines x plus 2ay plus a is equal to 0, x plus 3by plus b is equal to 0, x plus 4ay plus a is equal to 0 are concurrent, then the point a comma b lies on. For concurrency, the condition is that the determinant formed by the coefficients of all this should be 0. Right? This is the condition. Now, what is the easiest way to eliminate this? Make these two zeros. So I am going to do R2 replaced by R2 minus R1 and R3 replaced by R3 minus R1. So 1 0 0 2a a. This is 3b minus 2a, and this is going to be b minus a, and this is going to be 2a and this is going to be 0. So evaluating this determinant, 1 into this minus this is only this last term, minus 2a into b minus a is 0, which implies a is 0 or b is equal to a. Now this is the point a comma 0. They are asking about the point a comma b. Now if a comma b are a point, like if you consider a is x and b is y, this means x is equal to 0 and b is equal to a is x is equal to y, like, right? So this represents nothing but the x-axis, sorry, y-axis. X is equal to 0 is y-axis, and this represents a line like this. So the solution is this part, the y-axis and this line. So it represents actually a pair of straight lines, which is option B. Very simple question. Evaluate the determinant and show what is the curve here. This curve is neither a circle nor a parabola nor a hyperbola. Now let us begin question number 21, the subjective part onwards. If y minus 2 is equal to 0 is the directrix of the parabola, and the parabola intersects the circle x squared plus y squared is 8 at two real distinct points, then the absolute value of k is how much? Okay. Now let us find the directrix of this parabola, and that will help us to find the value of k. Minus 32, or this can be written as k times y minus 32 by k. Now this parabola is of the form capital X squared is 4a capital Y. Therefore the directrix is y is equal to minus a. And now we know that the 4a here is k, therefore a is k by 4. So the directrix is capital Y is minus a, or y minus 32 by k is minus k by 4. This gives us y is 32 by k minus k by 4. Now we know that y is equal to 2 is the directrix, is given. Therefore 32 by k minus k by 4 is equal to 2. A bit of simplification and I get 128 minus k squared by 4k is equal to 2, or this becomes k squared plus 8k minus 128 is 0. There is nothing but k plus 16 and k minus 8. Therefore k is minus 16 and 8. Now we have two parabolas. Okay. Now if I have k is 8, then this parabola is going to be x squared is equal to 8 into y minus 4. Okay. Now this parabola has vertex 0, 4 and it is open upward, right? So this parabola, and if you remember that this circle is x squared plus y squared is equal to 8, has radius 2 root 2, right? 8 is 2 root 2 square. So this circle would be maximum 0, 2 root 2. This is 0, minus 2 root 2, and this is 2 root 2, 0, etc. But this parabola has vertex at 0, 4 and it is open upward. So it will not touch this circle at all. It will not intersect, not touch, nothing. K is equal to minus 16 on the other hand means the parabola is going to be minus 16 times y plus 2. You substitute minus 16 here and take minus 16 out, it becomes y plus 2. Now this parabola, of course I told you this point is 0, minus 2 root 2. Now this parabola's vertex is 0, minus 2. And this parabola is open downwards. X squared is minus 4ay form. No? So it is going to be like this. So this would intersect it exactly at 2 points. Alright. So of these two parabolas, this is the correct parabola. And therefore the correct value of k is minus 16. And the absolute value of k is plus 16. So the answer is plus 16. Alright. Question number 22. If z1, z2 and z3 are three complex numbers such that mod z1 is equal to mod z2 is equal to mod z3 is equal to 1 by mod of 1 by z1 plus 1 by z2 plus 1 by z3 is equal to 1. All are unimodular, then what is the mod of this? Now first of all, mod z1 is equal to 1 itself is a special class of complex numbers, no? Unimodular. When mod z is equal to 1, then z into z bar, which is mod z square, is also equal to 1, and this implies z is 1 by z bar, or z bar is 1 by z. That is, the reciprocal is the conjugate of the number. Now what is the advantage? Let us calculate this. We need to find this, right? Take the conjugate of the whole thing, that is the conjugate of the absolute. We know is nothing but the absolute of the conjugate. And this can be split, since conjugate can be split anywhere. And if you know that all z1, z2 and z3 all have modulus 1, then this condition is true. Z bar is nothing but 1 by z. So this is 1 by z1, this is 1 by z2 and this is 1 by z3. So therefore this is equal to 1, which is given. Therefore mod of z1 plus z2 plus z3 bar is 1, but mod of the whole thing bar is the same as mod z1 plus mod z2 plus mod of z1 plus z2 plus z3. This also should be equal to 1. If the modulus of the whole and the whole of the modulus is the same. Right? So sorry, excuse me, it is not 0, it is 1. Okay? Very simple, use this identity idea that for unimodular numbers, z bar is 1 by z. 23. The fourth term in the expansion of a binomial theorem problem, and they've given a very crazy looking binomial to the power 6. Now fourth term t4, we know, if you know tr plus 1 is tr plus 1 t of r plus 1 is supposed to be ncr, the first term power x n minus r and the second term power r. So t4, the fourth term, r is 3, would mean 6c3, the first term, that is x to the power 1 by log x base 10 plus 1. I am going to write it as half, right? Because square root of the whole thing is the whole thing power half. The whole cube multiplied by x to the power 1 by 12, the whole cube, right? n minus 6 minus 3 and 3. This is 1 by 12. So this t4 is given to be 200. 6c3 is how much? 6, 5, 4, 3, 2, 1, 20 basically. And here, if I have to simplify this a little bit further, this can become 3 by 2 into 1 by log of x base 10 plus 1 plus 1 by 4. 3 times 1 by 12 is 1 by 4. Now if you take this 20 to the other side, it becomes 10 is x to the power 3 by 2 dot 1 by log x base 10 plus 1 plus 1 by 4. Take log to the base x on both sides. Log to the base x on both sides. This would give me log 10 base x is now log x base x. This will vanish, become 1, and the whole thing drops to the front. 3 by 2 into 1 by log x base 10 plus 1 plus 1 by 4. Alright. Now you see here, if you put some y is equal to log of x base 10, let us say y is x base 10, this becomes log of 10 base x is nothing but 1 by y, right? And the change of base rule basically. Okay. So this becomes 1 by y is 3 by 2 into 1 by y plus 1 plus 1 by 4. So the LCM is 4 by y plus 1, so I mean 4 into y plus 1. So here I get y plus 1 and here I get another 2, so that is 6. So this equation is y plus 7 by 4 into y plus 1. So 1 by y is y plus 7 by 4 into 1 plus y is equal to this, or 4 plus 4y is y squared plus 7y, or y squared plus 3y minus 4 is 0, or y minus 4, y plus 4, y minus 1 is 0, and I get y is minus 4 or y is equal to 1. So y is log x base 10. So log x base 10 is minus 4 or log x base 10 is 1. This implies x is equal to 10. This implies x is equal to 10 raised to minus 4, 0.0001. Now we have also been given the condition x greater than 1 is given. Therefore this is chosen, this is not. So the answer is x is 10. So the value of x is 10. Very simple problem. Expand this and all carefully and take the log base 10. The last but one problem. Integral dx by square root of x plus cube root of x. You know, this is a very standard problem, right? The idea is to take x as t raised to 6. What happens? Square root of x is t raised to 6 power 1 by 2 t cube. Cube root of x is t raised to 6 the power 1 by 3, which is t squared. Therefore, and of course dx is 6 t power 5 dt. So this integral becomes 6 into t power 5 dt upon t cube plus t squared. Now if I take a t squared and cancel it with the numerator, that is t squared here, and this becomes t plus 1. This reduces to t cube. So this integral is 6 times t cube upon t plus 1 dt. So divide t cube by t plus 1. I do synthetic division as always. T plus 1, I have to put minus 1 here. So 0, 1, minus 1, minus 1, 1, 1, minus 1, minus 1. So the remainder is minus 1. Please note that. So this integral becomes 1 is, this is the units place t squared. So t squared minus t plus 1, then minus 1 by t plus 1, because that is the remainder. Now if I integrate, I get t cube by 3 minus t squared by 2 plus t minus ln or log, as you like. Let's keep it as ln to compare it easier with the question. T plus 1. Now multiply 2t cube minus 3t squared plus 6t minus 6 ln t plus 1. Okay. Now you know t cube is root x, t squared is cube root of x. So this is root x, this is cube root of x. So the final answer is 2 into root x minus 3 into cube root of x. And the same way, 6t, t is 6th root of x, right? So plus 6 into 6th root of x, this is 6, and then minus 6 into, log of t plus 1, t is again 6th root of x, ln of 6th root of x plus 1. Now they have given that this integral is a into root of x, b into etc, etc. So let me write that down here. They have given this is equal to this plus cube root of x into b plus 6th root of x into c plus ln of 6th root of x plus 1. Comparing this, you get a is 2, b is minus 3, c is 6, d is minus 6. So we are asked to find the value of 20a plus b plus c plus d. This would become 40 minus 3 plus 6 minus 6, which is 37. So the answer to this problem is 37. It's a very standard problem in integration. Take t power x is t power 6 and then it is solved easily. The last problem of the question paper number 6. F of x is given to be x squared e power 2x minus 2 in the region, I am writing it like this, 2x minus 2 in the region 0 to 1 included, and then f of x is equal to the sine of x plus 1. Now sine of x plus 1, you know, is either positive or negative. If x is positive, sine of x is positive, x is negative, sine of x is negative. Since it is a positive region, this whole thing is going to be positive always, so I am conveniently going to forget about that sign. So it is just a cos 2x minus 2 plus bx squared in the region 1 to 2, open interval 1. If f of x is differentiable at x is equal to 1, then the value of a minus b is. Now if it is differentiable, the function must be continuous and its derivative must also be equal, right? So first, for continuous, at x is equal to 1, f of 1 can be evaluated from this function, right? That is this function, because 1 is included. So that would give me 1, here this becomes 1 into e raised to 2 minus 2, which is 1 in the end. And limit x tends to 1 plus of f of x using the second function would be a cos 2 into 1 minus 2 plus b, which is a plus b. These two values should be the same, right? The limit of x tending to 1 to this function and the value of this function itself. So this call this equation 1. Now let's find the derivative. The derivative of 1, okay, we can use this for the left limit, and this for the right limit, right? So the derivative df by dx as x tends to 1 minus would be from here. This would be x squared into e raised to 2x minus 2 into 2 plus e raised to 2x minus 2 into 2x. Now at x is equal to 1, this becomes 1 into 1 into 2 plus 1 into 2, basically 4. Right. Let us calculate the right limit from here. That is df, taking this function, a into cos of 2x minus 2 plus bx squared. We will find d by dx of f for values of x greater than 1. So this is nothing but minus a sine 2x minus 2 into 2 plus this would become 2b x. At x is equal to 1, this becomes, substituting x is 1 here, this vanishes and this becomes 2b. So for differentiability, 2b should be equal to this 4. So b should be 2, and substituting 2 in the first one, I get a plus 2 is 1 or a is minus 1. And they are asking us what is the absolute value of mod difference of a and b. It is minus 1 minus 2, that is mod of minus 3 or 3. So the answer is 3 for this function. Okay, very simple problem. Both continuity and differentiability have to be checked. Don't just rush into differentiability, because if a function is to be differentiable, it has to be both continuous and differentiable. So this brings us to the conclusion of mathematics part of the NTA test paper 6. See you again with NTA test paper 7. This is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad.